let's have a closer look to the decoder panel. There are mainly 4 integrated circuits for the CD player. And it's the series SAA. Later on they replaced, I think, almost everything into one at least. But this was maybe the very first set of integrated circuits. I already prepared this panel, not finished. Need to wait until I get some sockets and some caps, but all the caps are replaced. Some is already in a socket. We've seen this board is working, so quite boring. Cannot check anything because everything is okay. What is very important when you change all the caps, be sure that on top there should be a lot of solder. On unit 2 I put 2 less solder on the cap and then it was not working. That took me hours to figure out the problem. So if you run into any trouble and the board is not working, then check the service manual. It's very well described there. You need a 4-channel oscilloscope for the timing. I recommend to start really step by step going forward. So shortly explained, there's a dual flip-flop here. The signal goes first into the SAA70x0, which is the demodulator and decoder which prepares all the data. Signal goes then into the SAA70x20, the error correction. This is a memory for the error correction and repairs all the data and goes to SAA7000, which is an interpolation and muting, and it separates the channels from left to right. And those two are 16-bit. The SAA7030 is a filter and 4 times oversampling. And then the very famous TDA1540P, 2, one for the left, one for the right channel, 14-bit digital analog converter. Whoa, why there's 16-bit and 14-bit? Well, you can switch the SAA7000 from 14 to 16-bit. But why haven't Philips put in a 16-bit? I think that was one of the very first boards, and Philips invented the CD and they designed everything for 14-bit. And later on Sony joined Philips, and because they were more common to computers, maybe, I don't know. I do not know the exact reason, but they were going for 16 bits. So they then designed the chips for 16 bits, but maybe they have already designed these digital analog converters. Probably they don't want to throw them away because they cost a lot of money. So they used the 14-bit. So the question is, there are 2 bits missing, and the question is, can you hear the difference? To be honest, I can't. I absolutely can't. I think those digital analog converters have a very high quality. I think much better than 1-bit streaming decoders you get nowadays. However, the analog signal is then amplified here by some op amps, and here's the output. What I've done here is to replace all the caps with audio grade capacitor caps. So that's the best thing we can do. There's also some modification available. For instance, some are removing the oversampling. You can put in some bridges, and then you have to switch to from 16 to 14-bit or somehow. And you can also add new capacitors at the back, all the small capacitors. You can add more. some information on the web available for this? I don't think I'm doing this. It doesn't look nice. They just put all the capacitors on top of them. It might be an idea to put everything on a socket and then create a PCB and make a nicer design with the capacitors. Another modification would be to use better op amps. In Unit 2 I'm using op amps from Analog Devices. So there are other op amps available. You might want to change them and test them. So if you run into any trouble and you check the mechanic, the CD mechanism, the CDM2, the famous swing arm mechanism from Philips, if you think it is working and you cannot get it working here, first I recommend to replace all the caps. That already can be a problem with the caps. Put everything on a socket helps you to replace and exchange, try to figure out which of the integrated circuits are not working. You can get them easily on eBay. I have a set, I think 3 or 4 chipsets about this, inclusive the TDA1540P. So this helps. On unit number 1 and unit number 2, the error correction chip was toasted or simply not working. Replacing it solved the problem. That's something you can do with trial and error, but check the voltages before, not that you are going to toast another chip. And if it's still not working, follow the service manual, check with the oscilloscope on all 4 channels. I recommend to fix them and not playing around. Well, of course with 4 channels you cannot hold anything, but it's reacting sometimes very straight. It can happen that the CD stops then, or you get errors, and don't think you can damage a chip, but it might give you the wrong signals. However, if you still cannot get it working, you might want to get a donor, and the perfect donor for the drive and the decoder is the Philips CD150. And here is the board from the CD150, and you can see it almost looks identical. I'm going to ignore the voltage preparations here, where it looks absolutely identical. Here's also some preparation of voltages. So it would be possible to remove those things here and even use the panel. You can use the panel and mount it into the CD555. We just need to do some changes, but the chipset, that's absolutely identical. They're using different op amps here, LM833N, and here it is a Motorola 34072. I don't know which one is better, up to you. But beside this, they're all identical. As you can see here, they're looking so similar. They just added more what was necessary. Oh, someone already exchanged here something. You can see on the soldier. Yes, can you see? So this was already fixed by someone. However, that would be possible, could be done. Maybe I'm going to change the data sheet and explain where all the connectors from the power supply need to go here. That would be a perfect donor. I've already got 2 of them, not necessary to use them, only used the CDM2 for unit number 2 and this nice one straight here. Now you are. I think this is looking beautiful, absolutely amazing. If you cannot hear anything, that's what I had in unit number 2 and it was, for instance, the soldiers. Just check them. There's also a mute circuit which you can check. Around the back are some transistors for switching to mute. Also maybe one of the op amp is not working. That can be done. To be finished with this panel, you just need to wait for the capacitors. A long waiting time for this. I don't have any others, so I keep them at the moment and well, put them on a socket later on. We're also doing a little bit of modification to this panel later. This will be another episode about all the modifications that could be done. Okay, now we're getting this panel back into the sound machine in all the single parts and going to continue with the equalizer panel. We've seen there are some scratches when you change the volume, so we need to clean the potentiometers, also replacing all the caps. And we're going to do this then also on the AM/FM panel. As always, thank you for watching and see you next time. Cheers!